This is an AS Further Mechanics 1 question on momentum and impulse. A small ball of mass 0.3 kg is released from rest from a point 3.6 meters above horizontal ground. The ball falls freely under gravity, hits the ground and rebounds vertically upwards. In the first impact with the ground, the ball receives an impulse of magnitude 4.2 Newton seconds. The ball is modelled as a particle. Part A, find the speed of the ball immediately after it first hits the ground. So to do part A, it's going to require two separate calculations. The first calculation is going to be to find the speed that the ball hits the ground, and then use that speed to work out the speed that it rebounds from the ground by using the impulse. Let's draw a diagram so we can see what's going on. So here's my ground down here, like this. The ball is dropped from rest, so this is like the path of the ball. So from rest, that means that its initial velocity is 0. It drops a distance of 3.6 meters. So that's its displacement. Because it's dropping, it's under the effect of gravity. So we've got gravity going down, a value of 9.8, so that's G. And what I want to do is to work out the speed here, V, the speed that it hits the ground. Now when it hits the ground, we're told that the ball receives an impulse of 4.2 Newton seconds. So this arrow represents my impulse, the impulse that the ground gives the ball, like this. And then I would have worked out this velocity here that it's hitting the ground. Let's call that V. And I want to calculate the velocity that it rebounds from the ground. And I'll just use the next letter in the alphabet. We'll call that W, rather than call it V again and calling this U. It just causes a bit of confusion. So that means when I do my impulse equation, I will be taking the same direction as the impulse as positive here. So for my impulse, I'm taking upward as positive. Actually, for my suvat in a moment, I'm going to be taking downwards as positive. Okay, so let's work our way through, starting with suvat, S-U-V-A-T. So it's released from rest, so U is 0. Its displacement from the point at which it's released to the ground is 3.6 meters. So displacement 3.6. We're trying to find V, and A is going to be 9.8. So as I said, I'm taking downwards as positive. Seeing as we have S, U and A and we want to find V, then the equation we're going to use is V squared is equal to U squared plus 2AS. It's always good practice to write your equation down that you're going to use, even though you won't get a mark for it. It just helps you as you go through your working. Now we'll substitute V squared, so V is our unknown, U squared, so 0 squared, plus 2 times by 9.8 times by 3.6. So from that we can work out what V squared is, and that will just be 2 times by 9.8 times by 3.6, given a value of V squared is 70.56. We'll square root that to find V, so square root of my answer gives me 42 over 5, that's 8.4, so we'll just write that as 8.4. So that means that this value here is 8.4, that equals my V. Now when I do my impulse, okay, I'm going to be taking up as positive. So that means that V is going to be negative in my working because it's going in the opposite direction to my positive, and W is going to be positive in my working. So I'll write out the impulse equation. I is going to be equal to the mass M and then the velocity afterwards, W minus v. It's the velocity afterwards minus the velocity before. So that's velocity, not speed. That's why we include a plus sign or a minus sign. So the impulse is 4.2 Newton seconds. I'll write 4.2 is equal to the mass. That's 0.3 kg. W is what I'm trying to find, minus, now look at the direction of V, it's down, so this needs to be written as negative 8.4. So W minus negative 8.4. First step, I'm going to divide both sides by 0.3, so I'll do 4.2 divided by 0.3, and that gives me 14. So I'll have 14 is equal to W, and then minus negative 8.4 will be plus 8.4. So that means that W is equal to 14 minus 8.4. So that gives me a value of W as 5.6. And it's always good practice to write the units, so meters per second, as we're working out a velocity. Part B. Find the kinetic energy lost by the ball as the result of the impact with the ground. So KE loss, kinetic energy lost, is going to be equal to the kinetic energy that we had before the collision, before it hit the ground, so I'll just write before, minus the kinetic energy after. There's always going to be less after than there was before. So that will be half m. Now the velocity before was v, so half m v squared minus half m, and then the velocity afterwards is w, so half m w squared, and we just substitute that in now. So half m is 0.3 times by v squared. So we worked that out, didn't we? We worked out v as 8.4. So 8.4 squared minus half times by 0.3 times by the speed after the collision with the ground, 5.6 squared. So the kinetic energy before, if we work that out, is 10.584. And the kinetic energy afterwards is 4.704. So if we do the subtraction, we get 5.88 joules. Now, since our loss of kinetic energy is derived from velocities which were calculated using G to two significant figures, then we need to give our answer to no more than three significant figures. So we can give this answer of 5.88 joules, because that's fine, to three significant figures, or we can give our answer to two significant figures but no less, as 5.9 joules.